Hello everybody. We are discussing today the topic ray optics. I am Srinivasa Charyulu. Let us consider first of all how many questions we can get from this. Generally 2 questions to 3 we can expect from ray optics. Most of the questions are directly formula oriented. So before taking up the concepts of this, let me remind you some of the formulae of this topic. Ray optics, when we consider, mainly we have to remember that velocity of light is inversely proportional to the refractive index of the medium. In other words, we can say C1 by C2 is equal to mu2 by mu1. In the same manner, we can take wavelength of light in a medium is inversely proportional to the refractive index of the medium. In other words, we can say lambda 1 by lambda 2 is equal to mu2 by mu1. These are the basics first of all. After that, of course, we people are having the concept of lenses like. When we consider a lens like this, that too the lenses are in combination this way. If its focal length is f1 and its focal length is f2, 1 by f is equal to 1 by f1 plus 1 by f2 is the formula by means of which effective focal length of the combination can be calculated. But we know pretty well 1 by focal length, that is reciprocal of focal length, is called focal power. So focal power of the combination will be simply P1 plus P2. Exactly in the same manner, by any chance, 2 lenses are separated by a certain distance, say x like this, when their focal lengths are f1 and f2 respectively. 1 by f is equal to 1 by f1 plus 1 by f2 minus x by f1 f2. This is the formula one has to remember. Now focal power of the effective system, that now will be P1 plus P2 minus x into P1 into P2. So this is actually the way we people used to take up. Only one point to be remembered in both the cases: if at all the lens is concave by nature, we people used to write its focal length with a negative sign by convention. So this is one area we people have to remember. Come to the next one. What are the conditions for obtaining total internal reflection in general? Total internal reflection is going to be obtained under few conditions. The very first condition is this, that light should pass through, rather pass from a denser medium into a rarer medium. That is the first condition that is needed. And secondly, angle of incidence must be greater than the critical angle. And we know at this critical angle, mu is equal to 1 by sin C. But what is this mu to be called? It is mu denser with respect to mu rarer. That is the formula one should remember. So these are the points, and of course theoretically speaking, the sparkling nature of a diamond is due to total internal reflection. The formation of mirages, they are due to total internal reflection. Like that, of course, optical fiber is based on the same principle of total internal reflection. What is the concept of optical fiber over here? Mu of core is going to be greater than mu of cladding. This is one condition you people have to remember. And secondly, what should be the value of angle of incidence for total internal reflection to continue across the optical fiber? This is what is called launching angle actually, that now can be written sin inverse root of mu2 square minus mu1 square. Out of that you all can understand mu2 is of the core and mu1 is of the cladding. So this is the formula for optical fiber when we have been asked rather to write what is the launching angle thereafter. These are the points under total internal reflection you have to remember. Likewise, whenever we take a small application of this, a fish is under water and it is at a depth, say h, from the surface of water. It is looking into the outside world through a circular aperture like this. then of course the radius of the circular aperture they may ask you people to calculate. Now here you should understand this must be 90 degrees means this angle must be critical angle. Even this angle also must be critical angle. Then what will be the side length here? H square plus R square under root is the side length. So we can remember sin C is equal to 1 by mu according to critical angle concept, that is equivalent to R by root of H square plus R square. This is actually the formula by means of which any problem that is going to be asked on this fish concept, one can directly solve it. That is one area. Now come to the next concept and the last one over here please. Whenever they ask you the concept of a prism, prism has got I plus E is equal to A plus D is the first formula for us. A for angle of incidence, E for angle of emergence, A is angle of the prism or refracting angle, you can remember, and D is called angle of deviation over here. Coming to the next one, R1 plus R2 will now be equal to A. That means R1 is the angle of refraction at the first face of the prism, R2 is angle of refraction at the second face of the prism. The sum of these two values will now be equal to the angle of the prism. So this is the second one. Of course we know very well, at minimum deviation position we can write angle of incidence will be directly A plus dm by 2. That you people can all understand directly, angle of the prism plus angle of minimum deviation by 2. Likewise, angle of refraction is going to be A by 2. So taking these two concepts into account, we can rewrite mu is equal to sine of A plus dm by 2 whole divided by sine of A by 2. This is the formula which is called prism equation as such. Out of that, mu gives you the refractive index of the material of the prism with respect to air. That is actually the formula. By any chance, if angle of the prism is less than or equal to 10 degrees, then that type of a prism is called small angled prism as such. That time, we people used to write the same equation this way, mu is equal to A plus D by A. So in other words, you can say D is equal to A into mu minus 1. That is the formula one should remember for a small angled prism like that. Likewise, come to the last point please. When a lens of focal length f is dropped into a liquid, what would be its nature inside the liquid, they can ask you, or what should be the focal length or focal power of that particular liquid inside of that particular lens inside that liquid, like they can ask you. For that, better remember a direct formula this way: focal length of the lens in liquid by focal length of the lens in air. In other words, you can rewrite the same thing this way: focal power of the lens in air by focal power in liquid. So power in air by power in liquid, or focal length in liquid by focal length in air, is equal to mu glass minus 1 into mu liquid by mu glass minus mu liquid. Where from we people used to get this formula officially? That formula can be obtained from lens maker's equation, which of course is P is equal to 1 by F is equal to mu minus 1 into 1 by R1 minus 1 by R2. This is what is called lens maker's formula. Based on this, we can directly take this resultant and remember carefully as a condition, if at all mu glass is greater than mu liquid, then you can all understand here that lens behaves like a converging lens. Converging lens inside the liquid means that is going to behave like a convex lens. If at all mu glass is less than mu liquid, that behaves like a diverging lens. What is this diverging concept? It behaves like a concave lens inside the liquid as such. By any chance mu glass and mu liquid are equal, it behaves like a plain glass plate, that in the sense the value of focal power, which of course we people used to take over here, focal length becomes infinity. Focal length is infinity means that is possible only for a glass plate, that is like plain glass plate. We people used to find that its behavior is like that. So these areas, if you people are thorough with, certainly you can work out almost every question that is asked on ray optics in brief. So about these concepts, today we are just taking up some of the applications, please. Let us now start doing some of the problems as usual. So let us take the very first problem over here. Look at that. A bird in air is at a height y above the surface of water. A fish at a depth x below the surface of water. If refractive index of water is mu, then the apparent distance of the fish from the bird is how much? Look at one simple concept, please. This is the surface of water. This one is the position of the bird. At what height it is located, he has given very clearly, that as y. And this one is the position of the fish inside water. At what depth it is located, he gave that one as x. And refractive index of water is given as mu. Now here you should understand two things very clearly. One, when we people are in the rarer medium and when we are looking into the denser medium, certainly due to refraction, the bottom of this particular lake will now be seen as if it has been elevated a little. That means what? From rarer medium, when we are looking into a denser medium, then refractive index of that denser medium with respect to rarer medium is equal to real depth divided by apparent depth. This is actually the formula you have to remember. I repeat, when we are in the rarer medium, looking into denser medium, here of course bird is in air, looking into water, which is said to be denser medium over here. Air is rarer medium. So when it is looking from rarer into denser, mu of denser medium is equal to real depth by apparent depth. Now you can all understand what is mu of denser medium given. It is mu. What is the real depth of the fish, please? X. By what will be the apparent depth? I just want to know. So what can we write now from this one? Apparent depth in this particular case is equivalent to x by mu as such. Look at this concept carefully. X by mu is going to be the apparent depth for the bird. And at what height that is already located? It is at a distance y. Therefore, what will be the total distance now? It must be y plus x by mu. Look at which option that is tallied with this one. X by mu plus y, that is the third option that is given correctly there. But one thing you should understand, by any chance, if you are inside the denser medium and looking into the rarer medium, then you have to just interchange this terminology. That time mu denser with respect to rarer becomes automatically apparent depth by real depth. That is the formula what you have to understand. So for this first question, the correct answer is going to be the third option, please. Let us take the second problem as such. Let us read that. Light takes time t1 to travel a distance x1 in vacuum, and the same light takes time t2 to travel a distance x2 in a medium. The critical angle for that medium is how much? That is the concept. First thing you need to understand is, in vacuum he is talking about. Vacuum, whenever he is giving, it is understood it is rarer medium. So what is the value? Time is given t1, x1 is given the distance. Then what will be the velocity of light in that one, please? It is distance by time, that is velocity in vacuum. Now come to the second one, please. In a medium, that means certainly that will be a denser medium. T2 time it is taking to travel a distance x2. Then what will be the velocity over here? C2 becomes x2 by T2 as such. That is the concept. Now what is this question? What is the critical angle is the question. Mu denser by mu rarer this is nothing other than mu of denser medium with respect to rarer medium, that is equal to velocity of light in rarer medium divided by velocity of light in denser medium is equal to 1 by sin c. That is the formula you have to apply. That in the sense, what is velocity in rarer medium now? It is now, you can understand, this implies sin c is equal to c denser by c rarer. Remember this direct formula. What is c denser now? It is x2 by t2. What is c rarer? x1 by t1. So just take that cancellation please, direct value. C will be sin inverse. Okay, what will be there now? x2 t1 by x1 t2. Just a simplification you check once again. T1 goes up to the numerator and t2 comes into the denominator. x2 t1 by x1 t2. Which option that is going to be true here? You just look at fourth option is going to be correct. So if you can directly remember this formula, sin c is equal to c denser by c rarer, or else mu rarer by mu denser. Directly also you can work out this type of a question. Let us check the next problem, problem number 3. A bird in air is at a height y above the surface of water. Same problem, but the other way he is asking. A fish at a depth x below the surface of water. If the refractive index of water is mu, the apparent distance of the bird from the bird is how much? From the fish, in fact, this time we people have to take up. Now the concept here you have to understand is, earlier we have calculated from the bird. Now we want from the fish. Now this is the bird. At what distance once again it is located? Y. This is the fish now. At what depth it is located? It is given as x. And of course refractive index is given as mu. Now fish is looking the bird. Looking at the bird means what? Fish is in the denser medium, it is looking into the rarer medium. Then what is the formula to be taken? Mu denser by mu rarer is equal to, right, real depth, that is apparent depth by real depth. Apparent depth by real depth. That is actually the concept. You can definitely understand mu rarer is mu of air, that's value is 1, we all know. Then automatically what will be this value of apparent depth in this particular problem please? Real depth into mu. What is real depth to that particular bird please? It is y. Therefore, is it not mu times y please? Then what will be the total distance of the bird for the fish is the question. So is it not x plus mu y as such? Look at this option where it is given there. X plus mu times y. The very first option you look at, x plus mu y, it is very clearly mentioned there. Means what? When the bird is looking at the fish, we should consider mu is equal to real depth by apparent depth. When the fish is looking at the bird, it should be considered as apparent depth by real depth is equal to mu. So both are equally wonderful models as far as the concept of apparent depth that is concerned. So this is question number 3 what we are having. Let us take the next problem. Problem number 4 this time. A small air bubble is inside a transparent cube of side length 24 cm and of refractive index 4/3. If the apparent distance of air bubble inside the cube from a face is 9 cm, then the apparent distance to the bubble from the opposite face will be how much? This in fact one can directly understand by taking this figure please. Suppose if you are having a cube like this. I am just talking about one face which you can see from one end. Now, there is a bubble inside. Maybe the bubble may be right at the midpoint. That is a different issue. But whatever, when you are looking from this side, you feel as if the bubble is shifted this side a little. That means apparent depth will be less than real depth. Like that, when you are seeing from this side, you will find this particular bubble is shifted this side now. That means once again apparent depth is less than real depth. So what is the formula? Where from we are looking at once again? From rarer medium we are looking into denser medium. Then what will be the formula? Mu is equal to real depth divided by apparent depth. This is actually the formula one should remember. I have already told you in the beginning itself. So, real depth by apparent depth in this case. What is this real depth? It is nothing other than the total side length of that. This is 24 centimeter. That is real depth. By apparent depth from one end is given 9 centimeter. From the other end we don't know. That I take it as x. So, I can write this one as 9 plus x. But what is the value of mu that is given? Mu is given 4 by 3. Now, you can directly cut this one 6 times please. So, cross multiplication gives you 9 plus x is equal to 18. Then automatically x becomes how much please? 9 centimeter. So, what is the distance to the same bubble when we are seeing from the opposite side of the cube is the question. What is the distance again? 9 centimeter like the first one itself. So, check those options once again. Third option is going to be the correct option for this problem number 4. That is the concept. Look at the next number. That is problem number 5. A ray of light is traveling from a denser medium into a rarer medium. The velocity of light in the denser and rarer media are 2 into 10 power 8 and 2.5 into 10 to the power 8 meter per second respectively. Then the critical angle for the media will be, in fact, critical angle one should remember thoroughly. Of course, we know sin C, just now we have discussed it in one of the cases earlier. Sin C is equal to the velocity in the denser medium divided by velocity in the rarer medium. What are the values he has given? You see, denser medium he has given that one as 2 into 10 to the power 8. Rarer medium that is given as 2.5 into 10 to the power 8. Now cut these two values over here please. So 2 by 2.5, can't you simply write 4 by 5 please? Because 0.5 cancels here 4 times. 0.5 cancels here 5 times. So sin C now is going to be 4 by 5. What is the critical angle? The question for us. So sin inverse 4 by 5 must be the corresponding critical angle in this particular problem as such. Look at that question number 5, sin inverse 4 by 5. So, second option is supposed to be the correct option for this particular problem number 5. Okay, let us check the next problem, that is problem 6 please. A fish looking up through water sees the outside world contained in a circular horizon. If refractive index of water is 4 by 3 and the fish is 12 centimeter below the surface of water, then the radius of this circle is how much? Already I have told you this is one of the excellent applications of total internal reflection as such. This is the circular horizon through which this particular fish is now looking into the outer world. This is the position of the fish as such. Remember that. Now you can certainly understand this will be the radius and this particular ray, whatever is touching the circle over here, it should graze the surface, making angle of refraction 90 degrees. That time this angle of incidence is to be called as a critical angle there. So when this angle is critical angle, even this also is a critical angle according to mathematics. So if I take this one as the depth h and this one as the radius r, then what will be sin C here? Opposite by hypotenuse. What will be hypotenuse value here? H square plus r square under root. I now can write r by root of h square plus r square. This must be equal to what? 1 by mu, because sin C is equal to 1 by mu. Come on, equate these two values and finalize the result whatever you just want. What is it he has given as h please? 12 centimeter. Mu is given 4 by 3. Come on, substitute the values over here. R by root of 12 square 144 plus r square is equal to 1 by 4 by 3. That now becomes 3 by 4. Come on, square it upon both sides please. You will be getting 16r square here, right, is equal to 9 times, what will be the value here? 9 times 144 plus 9 times r square. Come on, bring that 9r square this side. 7r square will be 9 times 144. What is r the question? Root 9 is 3. Root 144 is 12. by root 7. That means how much it will be? 36 by root 7. Look at this particular option, search for this option there. 36 by root 7 is exactly the third option of this particular problem number 6. Therefore, third option is going to be the correct option for this question number 6, please. Right. So, this formula, if you can remember, any question related to fish inside water, which is an application of total internal reflection, everybody can work out easily. Let us check the next problem. Problem number 7. The radii of curvature of the two surfaces of a lens are 20 centimeter, 30 and 30 centimeter. Refractive index of the material of the lens is 1.5. If the lens is concavo-convex by nature, then the focal length of the lens will be how much? That is the concept. Concavo-convex. Observe this wording carefully first of all. We in fact should remember power is equal to 1 by focal length is equal to mu minus 1 into 1 by R1 minus 1 by R2. This is the formula what is called lens maker's equation. Based on this particular equation, this problem has been asked now. Now look at first of all, concave lens will be like this. This is known. And convex will be like this. That in the sense what? If you are not taking this line here, whatever is the shape you people are observing, that gives you concavo-convex. Now if I take, this is the axis. If you imagine that you are crossing the lens across the lens like this, if you look at that surface like concave, then take its radius of curvature with a negative sign. After entering into the lens, you can find even this one also like concave, then R2 also will be negative according to the convention. So, concave to be taken negative, convex to be taken positive. If you are looking at convex side, take the radius of curvature as positive, and if you are looking at concave side, take that radius of curvature as negative. Now, substitute these two values here first of all. Then 1 by f is equal to mu minus 1 into minus 1 by R1. Fine. This minus of minus, that now becomes plus 1 by R2. So, what are the values he has given? You just substitute. R1 is given 20, R2 is given 30, and the value of mu is given 1.5. 1.5 minus 1 is 0.5, which is 1 by 2, minus 1 by 20 plus 1 by 30. You now can write 1 by 2 into 60 if you take as LCM here, minus 3 times here, plus 2 times here, you will be getting that minus 5 by 2 into 60. You can definitely understand that. Minus 1 into by 2 into 60. Now, what will be this value? Minus 1 by 120 is 1 by focal length. Then automatically what will be the focal length over here? It should be minus 120 centimeter. That minus only shows that it is behaving like a diverging lens. But here he has not mentioned the sign. That means what is the focal length over here generally? 120 centimeter. So what is the correct option over here now? Third option must be the correct option for this question number 7. Look at that next number, that is problem number 8. A beam of parallel rays is incident on a transparent slab of refractive index root 3, making an angle 30 degrees with the surface of the slab. Remember this wording thoroughly. Surface of the slab he is talking about. Means what? If I consider this one is the slab, this one is a ray which is falling on it, called that incident ray. Usually, angle of incidence means between normal and incident ray, that is what is called angle of incidence. But here he is giving this angle, he has given you 30 degrees. Then what is the angle of incidence over here please? 60 degrees. Remember that point thoroughly first. So angle of incidence must be 60. And what else he has given you? Refractive index, that is mu, that is given root 3. Very clearly as mentioned. Now what he said? If the width of the incident beam of light is 1.732 millimeter, the width of refracted beam is how much? Width of incident beam by width of refracted beam is equal to cos I by cos r. A direct formula you better remember like this. Now what is angle of incidence? 60. But what will be this angle of refraction? Apply Snell's law please. Mu is equal to sin I by sin r. That is the formula. And of course mu is root 3 is equal to sin of 60 by sin r. I can write directly. What is sin 60 over here? Root 3 by 2 into sin r. Then root 3 getting cancelled. What will be left over? Sin r will be 1 by 2. That means r will be how much now? Simply 30 degrees. Now come on, write down those values please. Cos of 60 by cos of 30. What is cos 60? 1 by 2. What is cos 30? Root 3 by 2. Both the values of course we know. It now becomes 1 by root 3. Now what is the value of WR is the question. What is the WI that is given? Root 3 it is given 1.732 means. So WR is equal to 1.732 times root 3. This is also root 3, that is also root 3. So what should be the value of this width please? 3 millimeter. That means the fourth option is going to be the correct option for this particular problem number 8 please. But be careful about this equation directly. If you can remember this equation, you can avoid so much of calculation. Otherwise once again you have to calculate all these values please. So remember this is problem 8. Let us check the next number, that is problem number 9. A glass slab of thickness 4 cm contains the same number of waves as x centimeter of water column when both are traversed by the same monochromatic light. If the refractive indices of glass and water for that light are 5 by 3 and 4 by 3 respectively, the value of x. This is a very simple concept. In fact, looking a new problem like, but a very simple one. What is going to be the thickness he has given 4 centimeter into the refractive index of that particular glass, it is 5 by 3 is equal to, what is the other displacement or thickness we just want, into 4 by 3 as such. Come on, cut this 3 first of all. 4 gets cancelled on both sides. Then what will be left over? X must be now 5 over here. So what are the values he has given in centimeter he is giving? Then automatically this also should be taken in centimeter. So what will be the correct answer over here? X value must be 5 centimeter. Means the fourth option is going to be correct for this problem number 9 as such. Okay, let us check the next one please. Problem number 10. A ray of light from a denser medium strikes a rarer medium at an angle of incidence I. If the reflected and refracted rays are mutually perpendicular to each other, then the critical angle for the media is how much? One thing you should all understand here please. Reflected and refracted rays are mutually perpendicular to each other. That concept even if you find in the case of polarization as such. Of course, that is in physical optics, but it is related over here also because when reflected and refracted rays are mutually perpendicular to each other, then what is the direct formula? Mu should be equal to tan I. That is the concept. But of course we know while writing mu denser by mu rarer is 1 by sin c, here mu can be taken directly as sin c here. This is mu rarer by mu denser. Then what will be the critical angle please? Sin inverse tan of I. This is the formula. So what is the correct equation over here? Check all the 4 options please. Sin inverse should be there, tan I should be there. So first option only we have sin inverse concept. So automatically the concept is going to be sin inverse of tan I, which is going to be the very first option for this problem number 10 as such. Let us check the next number, that is problem number 11. The effective focal length of the lens combination shown in the figure is minus 60 centimeter. The radii of curvature of the plano-convex lenses are 12 centimeter each and refractive index of the material of the lens is 1.5. The refractive index of the liquid is. But here the figure is missing here. So I just will give you the concept of the figure please. We are having a plano-convex lens this way. We are having one more plano convex lens like this. Now in between these two, there is a liquid that is now totally filling the space between these two plano-convex lenses as such. This is the liquid what he is talking about. And what else he has given you? 12 centimeter is going to be the radius of curvature of each surface. This of course is having R 12 centimeter, even R of this one also 12 centimeter. What is refractive index of this liquid is the question, and what is refractive index of glass he has given, please? Glass value is given 1.5 and effective focal length of this entire system is given minus 60 centimeter. This is the total description one should remember before tackling this particular problem. Let us now work out. Are you not observing this is a plano-convex lens made up of glass? This is a plano-convex lens made up of glass. This is a liquid lens which is biconcave by nature, made up of the liquid. So how many lenses are combined in this particular system? 3 lenses we have. One plano-convex lens this side, a liquid biconcave lens over here in between, and one more plano-convex lens on the other side of it. This is what actually we have to take. Now tell what is its effective focal length, 1 by f1 for the plano-convex lens, mu minus 1 by r. All of us we know mu is given 1.5 minus 1, that is half, 1 by 2 into 12, 24. This is the value of 1 by f of this first part. What is this other one, please? 1 by f3 I write this one for this focal length. It is again mu minus 1 by r because that is also plano-convex lens, 1 by 24 again. But now check this one. What is this lens now? It is a biconcave lens. So 1 by f2 now should be written mu minus 1 into 1 by r1 plus 1 by r2, that is 2 by r with a negative sign I should write. Why negative sign? You can guess directly. This is a concave lens as such. What is this mu now to be taken? It is of that liquid what has been taken in between the lenses. Now come on, just to take this one like this, minus mu minus 1 into 2 by r is given 12. So you can even rewrite this one minus mu minus 1 by 6 you can take. Now what will be its effective focal length? 1 by f is equal to 1 by f1 plus 1 by f2 plus 1 by f3. That is official formula for us. Out of that, what is f value effective he has given? Minus 1 by 60. Is equal to 1 by 24 plus 1 by 24. This and this I can add 2 by 24, that is 1 by 12. Now what is 1 by f2 over here, please? Minus mu minus 1 by, what is this value? 6. So you can bring this value the other side, please. Mu minus 1 by 6 is equal to 1 by 12 plus 1 by 60. LCM you can take 60 here, 5 plus 1, 6. You will be getting mu minus 1 by 6 is equal to 1 by 10. Then what will be this value? Mu minus 1 is equal to 0.6 and mu will be 1.6 as such. What is this mu now? Mu of this liquid. Means what are the options he has given you? You see once again, 1.6 must be the effective value of refractive index of this particular liquid that is covering or that is filling the gap between these two lenses. So fourth option, which is the correct option for us. So whenever that fellow gives such a type of a construction, this is the formula based on which one should calculate the effective focal length or the refractive index of the liquid, or even focal power effective value also you can estimate from this formula as such. One of the very important formulae what we have of this chapter. Let us take the next number, problem number 12. A ray of light passes through an equilateral triangular glass prism such that the angle of incidence is equal to angle of emergence and the latter is equal to 3/4 of angle of the prism. The angle of deviation will be how much? One should directly understand this way now. It is a prism concept actually. Mu is sine of a plus dm by 2 by sine a by 2 formula generally we take up. Now he is giving us angle of incidence is equal to angle of emergence. I is equal to E. and the later, that means E is equal to how much? 3/4 the value of angle of the prism. What is the question is asking? What is angle of deviation is the question. It is based on a direct formula. I plus E is equal to A plus D. This is the equation which is valid for any kind of a prism. There is no particular condition that is required for writing this formula as such. So, I plus E, that is 3/4A plus 3/4A, right, minus A is equal to D. That is the concept. 2 times 3/4A means what? 3A/2 minus A is equal to D. Then what will be 3A/2 minus A, please? Is it not mean D is equal to A/2 directly? But very clearly he is talking about that the prism is equilateral triangular prism. What will be the angle of the triangle over there? The angle of the prism will be 60/2 will now be 30 degrees. So, what will be the value of D over there, angle of deviation? It should be 30 degrees. That means once again the option is going to be the fourth one for this particular question. Remember this formula thoroughly for these models as such. Look at that next number 13. Light falls at normal incidence on one face of a glass prism of refractive index √2. Then the angle of emergence when the angle of the prism is 45 degrees, that is how much he is talking. Normal incidence, that is the concept you should understand first of all. When it is a normal incidence over here, you can definitely understand angle of incidence will be 0. Angle of refraction at the first face also will be 0. Then can't you understand A is equal to R1 plus R2? Out of that R1 is 0. Then R2 is equal to A itself. What is the angle of the prism given? So, angle of the prism is given 45 degrees. R2 also is going to be 45 degrees. That is one point you should remember first of all. Now, what is angle of emergence is the question for us. So, directly you take mu is equal to sine of angle of emergence by sine of angle of refraction 2. Directly you can write sine E is equal to, what is the mu that is given? √2 into sine of 45. What is sine 45 once again, please? 1/√2. So, these two they get cancelled and you get 1. Then which sine of an angle is 1? That E now should be exactly 90 degrees as such. Look at once again the option there carefully. Fourth option once again is going to be the right option for this. So, this is the concept what you should understand. Normal incidence means angle of incidence will be 0 and angle of refraction corresponding to that particular face also will be 0 as such. That is the point. Look at that next problem, problem number 14. The refracting angle of a prism is A. Remember this wording first of all. Refracting angle is nothing other than angle of the prism. That is A is the angle of the prism. That's what he has mentioned. That is R1 plus R2. And of course he has given the refractive index of the material of the prism is cot of A/2. Then the angle of minimum deviation of the prism is how much? Mu is equal to sine of A plus dm/2 divided by sine of A/2. This is actual formula when the deviation angle is minimum in a prism. What is mu given? Cot A/2. Cot A/2 means what should I write? Cos A/2 by sin A/2. I can write that one. That means sin A/2 gets cancelled. What is now left over? You see, sine of A plus dm/2 now can be written as cos A/2 can be written as sine of 90 minus A/2. That is actually the concept. Now, can't you just equate these two? A plus dm/2 is equal to 90 minus A/2. That in other words you can write 180 minus A/2. This 2 gets cancelled. What is dm is the question. 180 minus, right, A minus A, that is 2A. That is actually the formula. Look at that option please. That you will be getting 180 minus 2A. 180 we write it as pi. So, pi minus 2a. Where is that option that is given? You see now, pi minus 2a means the second option that is going to be correct in this particular question number 14 as such. Look at the very next problem, that is problem number 15 now please. In an optical fiber, core and cladding were made with materials of refractive indices 1.5 and 1.414 respectively. To observe total internal reflection, the range of incident angle with the axis of optical fiber is, that itself already I have told you, that is called as launching angle. What will be the formula for launching angle please? Sine inverse root of mu 2 square minus mu 1 square. So what is this value here? You look at sine inverse root of, what is mu 2? That of the core, it's 1.5 whole square, 2.25 minus 1.414 means it is root 2. Root 2 whole square is 2. So you can get directly sine inverse root of 0.25. 0.25 will be how much? 0.5 under root 2. 0.25 means that is 0.5. So sine inverse half, that of course you can understand I should be 30 degrees over here. Look at this value. He is giving you asking you the range. Therefore, it should be between 0 and 30 degrees. Look at that option 3 please. 0 to 30 has given you. So third option is going to be the correct option for this particular problem number 15. Look at the next one please. Problem 16. ABC is a right angle glass prism of refractive index 1.5. Angle A, angle B and angle C are 60, 30 and 90 respectively. Let us just draw one small triangle over here please. Right angled triangle this way he is talking. Now this angle is given 60, this angle is given 30, this angle is given 90. That's what he is talking. Then which one? 60 means it should be A, and of course 90 means it should be C, and this one must be B. What is it he is asking you? You see now, for a ray of light which is incident normally on AC to be totally reflected at AB, the refractive index of the liquid on AB is, there is a liquid layer that is formed on this one. What is refractive index of the liquid is the question he is asking. Very, very simple question. Now if it is falling at 90 degrees, normal, then you can understand it now internally reflects like this. Then when this is 60, this angle will be 90 and this angle will be 30. Then what will be this angle of incidence over here please? 60 degrees. So what will be critical angle over here? That is going to be 60 degrees now. That is the point what you just have to take up. Now you can write mu liquid by mu of that glass or that solid, whatever we people are getting, that value is now going to be this value of sine 60. That is actually the case. That is sine C. You can directly write. Now what is mu of the liquid is the question. So you can directly write sine C, mu of liquid is equal to sine of 60, it is root 3 by 2 into the value of mu of glass. How much that has been mentioned over there please? 1.5 you just take. Now of course if you multiply these two, root 3 1.732 by 2 into 1.5, whatever the value you people are getting for this question, you will be getting around 1.29 for this. So that 1.29 whatever we are talking about is to be taken around 1.3. So third option is going to be the correct option for this question number 16. Look at the next one please, that is 17th problem as such. A prism is made up of material of refractive index root 3. Angle of the prism is A. Then the angle of minimum deviation is equal to angle of the prism. Then the value of A is how much? Angle of minimum deviation is equal to angle of the prism is the criteria. So you can write now mu is equal to sine of A plus A by 2 by sine of A by 2. Because dm and a are equal. Now you can write this one sine 2a by 2 by sine a by 2. All of you of course can understand this is sine 2a formula, like 2 sine a by 2 cos a by 2. If I take this formula divided by sine of a by 2, then what will I get? Sin A by 2 gets cancelled. Now mu is equal to 2 cos A by 2. That is the concept officially. What are the values he has given you? You see there. He is just asking you what is the value of A. Now mu is given root 3. Then can't we write cos of A by 2 is equal to root 3 by 2. Root 3 by 2 means how much? Cos 30 degrees. Then what will be A by 2? It will be 30 degrees and automatically A becomes 60 degrees as such. What is the value of A is the question for us. It should be the fourth option, that is 60 degrees over there. So this is the method of calculating the value for 17th problem. Look at that next number 18 as such. A convex lens of focal length 0.15 meter is of a material of refractive index 3 by 2. When it is placed in a liquid, its focal length is increased by 0.225 meter. The refractive index of the liquid is how much? That is the concept. Already I have mentioned the direct formula for that. Focal length in liquid by focal length in air is equal to mu glass minus 1 into mu liquid by mu glass minus mu liquid. This is the formula. What is focal length in liquid? He is talking about it is increased by 0.225. Actually it is 0.15. 0.225 is increasement. Then how much it will be? 0.375 it will be. So 0.375, right, divided by what is the other value given? 0.15 is equal to mu of glass is given 3 by 2 minus 1 into mu liquid by 3 by 2 minus mu liquid. This is actually the formula. Now if you simplify this one, whatever the option you are going to get, you can just take it for granted. Look at that options please. 7 by 4 and 5 by 4. You will be getting the value of mu liquid over here as 5 by 4. Remember one more point. Mu liquid must be less than that of mu glass in this particular case. So that is the identification you need to have. Look at the next number, that is question number 19 please. A thin glass prism of 4-degree angle gives a deviation of 2.4 degrees. The value of refractive index of the material of the prism is how much? For a small angled prism, I have already mentioned the formula. D is equal to A into mu minus 1. That is actual formula. Now what are the values he has given you? You see, a thin glass prism of angle 4 degrees into mu minus 1 is equal to what is the value of D that is given? 2.4. Then mu minus 1 will be 2.4 by 4. How many times it goes? 0.6 times. So what should be mu now? 1.6 must be the refractive index of that particular small angled prism. So first option is going to be the correct option for this question number 19. Look at the next number please, that is 20th one. The refractive index of a material of a plano-concave lens is 5 by 3. Its radius of curvature is 0.3 meter. Focal length of the lens in air. Plano-concave, observe that wording carefully. 1 by f is equal to mu minus 1 by r with a negative sign we should take for concave. So what are the values he has given? You see there, refractive index is given minus 5 by 3 he has given, right, and minus 1 by what the value of r that is given, you see, it is 0.3. So can't you just write 1 by f is equal to minus, you take it like that only. This now becomes 2 by 3 into 0.3. That is the concept. Then what will be f now? 0.9 by 2 with a negative sign, that is 0.45. What are the units he has given you? You see there, meter. Therefore, minus 0.45 meter must now be the corresponding focal length. So which option that is correct there? First option is going to be correct for this question number 20. Let us check the last number in this particular order please. A ray of light incident at 15 degrees on one refracting surface of a prism of angle 60 degrees suffers a deviation of 55 degrees. The angle of emergence is how much? Once again, it is based on the basic principle. What is that? I plus E is equal to A plus D. Angle of incidence plus angle of emergence is equal to angle of the prism plus angle of deviation. That is the formula. Now we want E. What we should write? A plus D minus I. What are the values given? You see, angle of the prism is given 60 degrees, right? Angle of deviation, of course, he has just given on one, it is incidence, that is 15. Angle of deviation is given 55 minus 15. Now 55 minus 15 is 40. So 60 plus 40, which now should be 100 degrees. That should be the angle of emergence over here. Check those options once again. The fourth option, which is going to be correct in this particular case of problem number 21. Now if you just go on taking these concepts like up to the end of prisms, we people have discussed it today. In the sense, from this particular part, you can certainly expect one question in the final examination as such. What is now left over of this particular chapter? In fact, the important most concept that is left over, we people are having the concept of optical instruments. That is one part which of course is to be taken very seriously for our Eamcet studies. And second point in this particular case is regarding aberrations. What exactly are chromatic and spherical aberrations like, and how to minimize them also we people have to discuss. Exactly in the same manner, we people are having the concept of spectra, and of course aberrations. Along with that one, we have to deal with eyepieces. What are these eyepieces we people are having? One is Ramsden's eyepiece and one is Huygens eyepiece. So about these three, we people just are going to discuss in the next session of our physics class. But in the meantime, just try to work out as many questions as possible as far as this particular topic that is concerned, that in the sense up to the concept of prisms, whatever we people are having. I hope all of you might have understood, right, the values, the formulae and other things like. So naturally, if you work out few more questions, you will definitely get the idea about all the formulae and you become more and more confident about this particular topic as such. Thank you and good luck.